So paper code Q6, question number 6. The ratio of radius of gyration of a thin uniform disc about an axis passing through its center and normal to its plane to the radius of gyration of the disc about its diameter is. First we should write what is the value of moment of inertia for these two. Moment of inertia when axis is passing through center of the disc but perpendicular to its plane is mr square by 2. But moment of inertia when axis is along diameter of the disc is mr square by 4. Now, what is the value of radius of gyration? If we denote radius of gyration by k, then k is given by root of moment of inertia divided by mass. In this case, because we are talking about the same disc, obviously the mass is same. So k1 by k2, if I write this as k1, it should be I1, and k2 should be root of I2 divided by m. So the ratio of 2, if we divide these two equations, will give us k1 by k2 equals to under root of I1 by I2. Now the ratio of these two, I1 by I2, is going to be 2. So this is simply root 2 is to 1. Hence second option should be correct. We should move on to the next question. Now question number 7. The angular speed of a flywheel moving with uniform angular acceleration changes from 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration in radian per second square is. If angular acceleration is uniform, we can simply say alpha is delta omega divided by delta t. But what will be the value of delta omega? That will be 3120 minus 1200. But this value is in rotations per minute, and to convert rpm into radian per second, we should multiply this with 2 pi divided by 60. So this is the value of delta omega in radian per second, and then we will divide this by the value of time interval in which this change is taking place. So this is going to be 1920 divided by 16 multiplied with 2 pi over 60. So this will give us 4 pi, which should be the answer to this problem in radian per second square. So second option should be the correct option. We should move on to the next question. An ideal gas undergoes 4 different processes from the same initial state as shown in the figure. These processes are adiabatic, isothermal, isobaric and isochoric. The curve which represents adiabatic process among these 4 is. We should first see that this process 4 is definitely isobaric. This process 1 is definitely isochoric because volume is constant. But among these two processes, we should decide which one is adiabatic. Obviously, adiabatic process has got much more steeper curve, much more steeper slope as compared to isothermal process. So slope for isothermal process is given by simply minus P over V, while that for adiabatic process is given by minus gamma times P by V. That's why slope of adiabatic process is much more steeper. Hence, the process 2 must represent adiabatic process. So second option should be the correct answer. Next question. Two hollow conducting spheres of radii R1 and R2, R1 is much greater than R2, have equal charges, the potential would be. If we are talking about a conducting hollow sphere, then potential of such an sphere is given by kq, where q is charge on the sphere, divided by its radius r, which means potential is directly proportional to 1 by r. it directly means that the bigger sphere will have lesser potential for same charge. And the question is asking us that if two conducting spheres are there, then the potential would be more on bigger sphere? No, because bigger sphere will have lesser potential, more on a smaller sphere. So this should be the correct option. Next question. When light propagates through a material medium of relative permittivity epsilon r and relative permeability mu r, the velocity of light v is given by. Of course, if we write C in terms of permittivity and permeability, then it is given by C equals to mu naught multiplied with epsilon naught. But if we calculate speed of light in a particular medium, then it is given by 1 over root of mu for the medium multiplied with epsilon for the medium. And if we divide these two, then the ratio V by C is going to be 1 over root of relative permittivity and relative permeability. So V should be given as C divided by root of epsilon r mu r. Hence, option 4 should be the correct answer to this problem.